I already sent the link in the chat room. Today is 5 November. All right, Alia.
Yes, Miss.
Okay, Nada.
Hadir, Miss.
Arik. Arik. Okay, next, Nadif.
Present, Miss.
Are you okay, Nadif?
Okay, Miss. Okay.
Okay. Devinda.
Hadir, Miss.
Haidar.
Hadir, Miss.
Neta.
Miss.
Kai. Kayla. Not yet. Reza.
Hadir, Miss.
Farel. Rel. Okay, next, Fazil. Fazil. Nadia.
Hadir, Miss.
Okay. Nasiwa Kirana.
Hadir, Miss.
Nasiwa Gustia.
Hadir, Miss.
Olive.
Hadir, Miss.
Nazira. Nazira. Raisya.
Hadir, Miss.
Raka.
Hadir, Miss.
Santika.
Hadir, Miss.
Tabina.
Hadir, Miss.
Talita.
Hadir, Miss.
Delason. Nesa.
Hadir, Miss.
Oke. Arik udah di situ, Rik? Rik. Arik. Arik Anda. Kaila. Saya udah join. Kaila not join yet. Next, Reza. Reza. Oke. Fazil. Oke. Nazira. Alright. So, Kaila, who hasn't joined yet for today. Alright, guys. So today we will learn about acid and base. I already showed you the videos of the introduction of the acid and base. Now I want to check your knowledge, your prior knowledge about the last meeting, the last video that I already give you by using some question. I hope that everyone join the link. Oh, udah ada yang jawab ya guys. Wait. Please join the link, guys. And you can answer the question. The first question is, what do you know about acid and base? Only 2 people. Press the other. Okay. Acid donates proton and base accept proton. Good. If you measure acid and base with pH scale, acid number are always below 7. Starting from 7 above, is already bases. And while if the pH scale is and is pure water, acid release proton while base accept okay. Acid has pH. So this one is about pH. How about other? Let's we wait for a bit. Guys, another example or another definition about the acid and base except pH. There are a lot of pH here. If you see in your daily life, and you can see, oh, this one is acid and this one is base. Can you give me the example of acid and base in your environment, guys? Acid or substance that donates proton. It has pH below 7. There's a substance that sucks protons. It has pH below 7 or above 7. All right. Acid are usually known as okay, H plus or proton and bases as OH min or hydrogen. This one is hydrogen ions and this one is hydroxide ions. On the pH scale, acids are measured under 7 and bases are over 7. Okay. Acids have a taste. Bases are separate. Oh, okay, good. So from your answer, we can see that almost of you say that the acid has a pH below 7, while the base has pH above 7. That's correct, guys. And in the middle or in the 7 pH, we can call it as neutral substance, such as salt or water. And for another definition, like acid donates proton and base accept proton, we will learn about this one in acid and base theory. This is a good one. Acid turn blue litmus paper to red, whereas base turn red litmus paper to blue. Okay, good job. Acid and base are chemical reactions that each of them increase their own substance. Each of them increase what kind increase in this explanation, guys? Proton is for acid and hydroxide is for bases. Okay, good. We determine both of them by pH scale. Okay. All right. A base is a molecule or ion able to accept a hydrogen ion from an acid. Acidic substances are usually identified by their sour taste. Good. So in your daily life, you can identify, oh, this one is acid and this one is base. For the first thing, we can taste it. For example, like acid is our taste, and for base, it is you can touch it like a slippery. And but not all substance we can taste it, right? For example, like the substance in the lab, of course, it is really dangerous to taste the compound. That's why some of them we can use acid and base indicator, such as litmus paper. And I will explain you about the properties of acid and base, including salts, after this presentation. All right, guys. So, this one. Acid and base are the form of chemical that play a vital roles in chemistry and are readily available in our daily life. For example, acid including citric acid and lactic acid. Oh, good job, this one. Present in lemon and in dairy. Okay. Some example of base including, oh, ini nggak cukup ya penjelasannya. It's fine. Nah, this is the same of the acid and the same example of the base. All right. Acid can be in form of solid, liquid, or gas, from depending on the temperature basis, have a bitter taste, okay, having a bit slippery and solid appearance. Okay, good job. So almost all of you already know the basic concept of acid and base. Next question. How can we tell the differences between an acid and a base? Tadi beberapa dari kalian sudah jawab. We can test it including the taste, right? Acid is sour taste, while the base is bitter. And then we can touch it, like base is slippery. Next, we can use this acid and base indicator, right? Just as litmus paper, pepper, or the BTB. Oke. Next ya, ini tadi beberapa jawaban udah kalian jawab sebelumnya. Oke, good. It's okay, guys. Let's read next to the next slide. Acid remain colorless when dissolved, while base make the solution turn pink when dissolved. Base turn pink if we add indicator, such as phenolphthalein, PP or phenolphthalein. The scale pH of PP is, for the acid, if we add the indicator of PP, and it will remain colorless. But for the base, if we add the indicator PP, it can turn pink or almost like purple, something like that, guys. So just like I already explained to you about the indicator, we can tell, oh, this one is acid and this one is base. We use the indicators such as litmus or PP solution or BTB solution. Next slide. What's the other? Okay. Next ya. According to Arrhenius, which is the base? Sulfuric acid or aluminum hydroxide or phosphoric acid. Okay, good job. There are at least almost of you have the correct answer. It is aluminum hydroxide. So from the previous slide, we already know that the acid has hydrogen or release hydrogen ion, while base release hydroxide ion. From this example, you can see sulfuric acid, there is hydrogen here, while the aluminum hydroxide, there is OH ion, which is hydroxide ions, right? So in the Arrhenius theory, this one and this one is acid, while aluminum hydroxide is base. I will explain you deep about the Arrhenius or another term. Next, the last question. Which is pair of acid and conjugate base? Time's up. No, all right. For the acid conjugate base, it is Bronsted-Lowry theory, and we we uh, we will learn about this one after this. So after the lesson, I will give you another five questions to check your understanding for today, and I hope that you will learn or you will already know about the acid conjugate base after I explain you. So how it can become hydrochloric acid and chlorine ion, because in Bronsted-Lowry theory, it is depend of proton transfer. Tadi kan sebelumnya ada yang jawab tuh proton transfer. Nah, how can we call it as acid conjugate base or base conjugate acid in the next slide. All right, guys, for today, let's we see. Hi, Miss. Namanya Hi, Miss dong. Okay, good job for everybody, guys. Especially for the Twitter. Who is it? All right. So it is the basic concept of acid and base, and you will learn about acid and base and the theory of acid and base for today. Ding, ding, ding. So in this unit, you are going to learn about introduction, which is the properties, and the theory. There are three theories, and because we just learn in the Cambridge, and in the Cambridge for the acid and base, it is focused on the Bronsted-Lowry theory. So I put the Bronsted-Lowry theory in another explanation. It is about the conjugate acid base pair. And then the strength, which is there is weak acid, strong acid, and then weak base and strong base. Next is ionic equation. And the last is calculation of titration. The titration in acid and base, it is almost the same with redox, guys. So don't worry. We already learned about this. So this one, the properties of acid and base. And some of you already tell about the acid and base. So what is acid? Acid, of course, it has sour taste. And for the example, such drugs, in drugs, in paints, fertilizer or food, and soft drink and cooking ingredient, and even in our stomach, hydrochloric acid. So there is acid. Like citric acid in the fruit, and the sulfuric acid, and another example of the acid. Next, how about base? Base, it can oxidize and or hydrolyze of the metals. So there is OH min or hydroxide ions, guys. And for the acid and base, it can soluble in water, of course, but in acid, it can, if acid and base has high concentration, so it is really dangerous for our body or even for the metal itself. And the example for the bases such as soap, batteries, and another alkaline metals. And how about the salt? If we mix between acid and base, it will produce salt. So what is salt? Salt is the ionic compound from both of them, the reaction between acid and base. For example, like sodium chloride or table salt, zinc chloride, and another example. So before you know about chemistry, you just know about the table salt or the sodium chloride is a salt. But after this lesson, you will learn that the salt is not just sodium chloride, guys. there are a lot of kind of salt in chemistry. Tetapi yang memang yang terkenalnya adalah NaCl. Padahal garam itu banyak bentuknya. Why? Because there's a lot of acid and there is a lot of base. So acid and base we can mix together or react together. And the uses of salt is such as food preservative and the freezing mixture and another uses in our daily life. Next, we already learned about naturalization reaction and enthalpy, right? There are a lot of reaction type in the enthalpy, such as formation, solvation, combustion, and another one is naturalization reaction, which is the reaction between acid and base. Why it is said or it's called as neutralized? Because acid, the pH of acid is below the 7, pH of base is above 7, and then it can produce salt or water, which is the salt and water, the pH is neutral, which is 7. And for the example, we already learned about it before. And this is the example of the acid rain. We will learn about acid rain in the nitrogen and sulfur unit, guys. So I will skip this one. And this one is the properties of acid and base. You can see the taste, the touch, and the reaction with some metals. Taste sour for acid and for base is bitter. And touch, we can touch the compound of acid is often sticky, but base is slippery. And next, the reaction with some metals. Metals with acid, it can corrosion, guys, atau corrode the certain metals because acid and the metal will produce hydrogen gas. Nanti ada oksidasi reduksinya tuh di reaksi acid sama metals. While for base, there is no reaction with metals. Gitu. Karena acid biasanya yang lebih korosif dibandingkan basa. Next, electrical conductivity. Both of them can conduct electricity. Why? Because in the acid and in the base, they are produced ions. And these ions, they are cation and anion, will move around the compound or around the solution, and it can produce the conductivity. And how we can test the acid and base? Using indicator. Which indicator? There are two kind indicator. Ada yang alami, ada yang buatan. Yang alami contohnya apa? Contohnya we often use flower, guys. Ada bunga-bunga kayak bunga kembang sepatu, itu bisa kalian ambil airnya gitu dari kembang sepatu itu, and it will change the color if the indicator we put in the acid and indicator we put in the base. Contohnya kayak yang tadi sudah menjelaskan yang PP solution. Indikator PP itu kalau misalnya di acid dia colorless, tetapi kalau di base dia malah jadi pink. So using indicator we can test which is the acid and which is base. And how about the chemical formula? Usually, berarti tidak semuanya. Cuman biasanya atau umumnya itu in acid has a hydrogen ion atau HCl misalnya ada hidrogennya. While in base usually has a hydroxide ion atau OH-nya. For acid, hydrogen ion itu biasanya di left or di kiri. While base, hydroxide ionnya itu adanya di kanan. Karena kan positive and negative. So we put the positive first in the left side and then negative in the right side. because hydrogen ion is positive, so it is usually in the left, while hydrogen ion is negative, so in the right. Until this, any question, guys? No, it is clear enough.
Inshallah,
All right.
yes, Miss.
Okay, good job. Next, we go to the theory. Nah, in acid-base theory, in the national curriculum, guys, kalau di Kurnas itu kita belajar 3. Arrhenius, Acetylene, and Lewis. Nah, Miss kalian ngajarin istilahnya kayak gitu. Tetapi nanti pertemuan selanjutnya kita akan fokus on the Acetylene theory. Which is acid and which is base. In Arrhenius theory, acid is the substance that releases hydrogen ion in water solution, while base in hydroxide ion release hydroxide ion in water solution. And the reaction between acid and base for the Arrhenius, it is formation of water. For example, such as hydrochloric acid in the water, it will dissociate, become hydrogen ion and chlorine ion. Because in this process, hydrochloric acid release hydrogen ion, so we call it as acid, based on Arrhenius theory. While for the sodium hydroxide, it will dissociate in water, become sodium proton or sodium ion and hydroxide ion. Because in this process, it is released OH or hydroxide ion, so we call it sodium hydroxide is base according to Arrhenius theory. If we react together, acid and base will produce water. Ini menurut Arrhenius. But the weakness of Arrhenius theory is, in this Arrhenius theory, we just can indicate acid and base only in water solution. Jadi hanya bisa di dalam air saja, atau yang ada hidrogen sama OH-nya saja. Padahal there are a lot of substance that if we taste with the indicator, this one is acid or this one is base, tetapi substansinya itu tidak ada hidrogennya misalnya, atau tidak ada OH-nya, tetapi bisa terindikasi, oh dia asam sama basa. That's why after Arrhenius theory, we move to Bronsted-Lowry. Ada teori selanjutnya, yaitu Bronsted-Lowry, which is we often we call it as proton or proton donor and acceptor. Which one is donor? It is acid, and which one is acceptor? Which is base. Kalau ini mau ngomongnya H plus sama OH-, kalau di sini dia hanya ngomongin H plusnya saja. Hanya beda, acid is donor and base is acceptor. So, if the acid and base react together, there are proton transfer process. Nah, nanti di sinilah kita akan belajar which one is acid and base conjugate or base and acid conjugate. Example, guys. Proton donor, berarti ada yang didonorkan. Apa? Yaitu protonnya, H+. For example, A is acid, B is base, and BC, it is base conjugate, guys. AC itu acid conjugate. Salah. Nah, how can we call it hydrochloric acid is acid in this process? Pertama, you can see the pair in the reactant and then product. Ada HCl di reaktan, ada Cl- di produk. Ini pair-nya, guys. Kenapa pair? Karena tadi kita hanya ngomongin donor atau reseptor si proton. Jadi ngomongin yang ada H atau yang nanti tidak ada H. While hydrogen, water and become H3O ion, ini pasangannya juga pair-nya. Kenapa? Ada hidrogennya, ada oksigennya ada. Berarti itu pasangannya. Sementara di sini hidrogennya nggak ada, tetapi Cl-nya ada. Tadi, proton is donor. Acid is proton donor, sorry. Acid is proton donor. So, dari sini kalian bisa lihat, in the hydrochloric acid, there is one hydrogen. Tetapi di produk atau pasangannya, it is lose the hydrogen. Ya kan, kehilangan hidrogen. Berarti apa? Hidrogennya atau protonnya ini didonorkan. That's why we can call it ini acid, karena hidrogen yang tadi dia punya, dia donorkan ke basa. Yaitu kemana? Yaitu ke si H2O. Ini sebagai basanya. Kenapa ini sebagai basa? Karena ketika reaksi, in this reaction, H2O atau water, dia become menjadi H3O. Hanya nambah di sini. Menjadi 3. Berarti ada proses donor sama akseptor proton. Yang donornya adalah HCl sebagai acid, yang nge-accept si water itu sebagai base-nya. Nah, berarti pasangannya adalah kalau dia acid, pair-nya adalah base conjugate. Kalau dia base, pair-nya adalah acid conjugate. But in this theory, kalau tadi kan teori yang Arrhenius, it just only water solution, tetapi di Bernsted-Lowry dia bisa solution apa aja, guys. It's not only water. It can ada yang gasnya bisa, gitu, atau solution yang lainnya juga bisa. Tetapi in Bernsted-Lowry, the process only focus on proton transfer. Ternyata ada acid and base yang tidak berdasarkan proton transfer ini. That's why Lewis state for acid is substance that lone electron pair acceptor, while for base is lone electron pair donor. Jadi kalau ini mah electron pair, untuk Lewis fokusnya, pada Bernsted-Lowry itu proton, bedanya kan, Arrhenius itu H plus and OH-. Nah, donor sama akseptornya ini tinggal kebalikannya, guys. Bernsted-Lowry is donor, tetapi kalau Lewis acidnya dia malah akseptor. I hope that everyone still remember about Lewis structure. Karena ini ngomongin Lewis tuh, Lewis structure. Wait. Bentar, guys. Kebiasaan. Wait for a moment. This one. This one. Tadi ada Arrhenius, ada Bernsted-Lowry, and the last one is Lewis. Arrhenius, pokoknya dia ada hidrogen, sama ada OH-, right? So, hydrogen itu biasanya asidnya di left, for example like hydrochloric acid, terus sulfuric acid, and another one. Pada base, hydroxide ion itu biasanya hydroxide-nya ada di right side, contohnya sodium hydroxide. Terus calcium hydroxide. Next, aluminium hydroxide. And so on. Nah, kalau bronze lori itu kan ngomonginnya donor. Acid, ini base. Acid ini donor, proton. For base is acceptor, proton. Berarti apa? Ada yang tadinya ada menjadi H plusnya. Gitu. Contoh, hydrochloric acid. Tadinya ada. Terus tiba-tiba lagi ketika proses reaksinya, it lose or donor protonnya. Berarti nanti nggak ada di sini hanya, tetapi jadinya Cl-. Gitu. And for base, for example, with NH3 ammonia. Ammonia, we can call it as base bronze lori if tadinya amonia NH3 dia menjadi ammonium ions atau NH4+. Bisa lihat dari mana? Kalau di bronze lori kalian fokus protonnya, guys. H-nya 1. Di sini nggak ada H. Berarti dia mendonorkan, hilang H, yaitu acid. In this one, there are 3 hydrogen. Ada 3. Tetapi ketika di produk, dia nambah 4. Berarti CNH3 ini accept the proton. Berarti ininya adalah base, yang ini acid conjugate. Jadi pasangannya itu kalau ini basa, ini acid conjugate. Kalau ini asam, berarti ini base conjugate. And for the last theory, it is Lewis. Lewis, it is about the PEB atau pasangan elektron bebas. Bentar ya guys. Di pasangan elektron bebas itu kan ngomongin structure of Lewis. Structure of Lewis. For example, tadi contohnya adalah this one. Ada NH3BF3. Ini reaksinya ketika dia bereaksi dari amonia dengan boron fluoride become this one, and this is we call it as Lewis acid base. Kenapa? Karena in ammonia, ammonia there are 5 electron, right? Because in the 15 group, so 1, 2, 3, 4, 5. Terus and bonding with 3 hydrogen. 1, 2, 3. This is Lewis structure. Next, BF3. Boron only have 3 electrons. 1, 2, 3. And fluorine, there are 7 electrons. 1, 2, 3, 4, 5, 6, 7. Begitu juga dengan fluorine yang lainnya. Gini kan. So, in this one, H3 sama BF3, there are bonding or dative covalent bonding. Masih ingat nggak tuh? Dative covalent bonding. Kenapa? Because in NH3 ini, di amonia, dia ada pair elektron. Di mana pair elektronnya ini akan berikatan. Gitu. Set. Nanti ke sini. Digunakan atau berikatan. Nah, because pair elektron berarti Which one yang donor? Yang donor adalah si NH3 karena NH3-nya punya pair elektron. His pair electron. So, because this one is donor pair electron, we call it as ammonia is base or Lewis. Menurut Lewis dia basah. Kenapa? Karena ada proses donor elektronnya, pair of electron. Sementara BF3 menurut Lewis dia asam atau acid. Why? Karena BF3 accept the electron. Sehingga nanti berikatan menjadi NH3BF. So, this is the 3 theories of acid and base. Until this one, any question, guys?
Miss.
Yes.
Boleh ke slide yang tadi dijelasin nggak, Miss? Soalnya tadi resolusinya jelek banget, Miss. Ini share
Yang
screen.
dijelasin tuh yang mana, Matt?
Yang tadi yang Miss coret-coret. Itu tadi
Oh.
buram banget. soalnya.
Oke. Udah kehapus. Bentar ya. Jelas nggak? Kelihatan jelas PPT-nya?
Jelas, Miss. Jelas.
Oke, Miss ulang. Di teori acid base itu ada 3. The first one is Arrhenius. Second one, Bronsted-Lowry. And the last one is Lewis. Arrhenius acid itu adalah yang ada H+, ya kan? For example, hydrochloric acid or sulfuric acid, ada phosphoric acid. Pokoknya semuanya ada hidrogennya karena it will release hydrogen ion. And for base itu adalah release of amine, hydroxide ion. For example, sodium hydroxide. And next, potassium hydroxide. Terus, what else? Calcium hydroxide. Pokoknya semuanya ada amine. And for the Bronsted-Lowry, itu kita ngomongin apa? Donor sama akseptor proton. Acid, dia donor. Plus. Base, dia akseptor proton. Donor proton. Berarti apa? Berarti si asidnya itu yang tadinya punya proton, ketika bereaksi, dia kehilangan proton. Berarti yang tadinya punya H, di produknya dia hilang H. Begitu juga dengan akseptor proton. Yang tadinya dia nggak punya H, atau hanya cuma 1 misalnya. In the process reaction, produknya dia mendapatkan H, dapatkan akseptor proton. For example, ini biasanya in one reaction, guys. Contohnya, tadi apa tuh? Ya, misalnya H2SO4 dimasukin ditambah sama amonia atau air. Terus dia menjadi HSO4- dengan H3O+. In this reaction, kalau di Bronsted-Lowry, there are pair, which one is acid, pairnya itu adalah base conjugate. Terus kalau base, dia pairnya adalah acid conjugate. Gimana bisa ngelihat atau identify the pair? Kalian lihat the composition of the atom. Contoh, in sulfuric acid, ada hidrogen, ada sulfur, ada oksigen. because we about the proton transfer, jadi ada H-nya. Jadi H-nya itu kalian jangan terlalu diambil pusingkan. Lihat atom-atom selain H, for example, sulfur and oxygen. Dan di produk carilah compound yang ada sulfur and oxygen. Which one? This one. Nah, so this is the pair. Begitu juga dengan yang ini. Ada hidrogen, ada oksigen. Cari yang ada hidrogen sama oksigennya juga, atau hidrogennya hilang, atau menjadi oksigen doang misalnya. So, this one is clear. Yang mana acid, yang mana base conjugate, yang mana base, yang mana acid conjugate, tinggal lihat jumlah hidrogen. Di reaktan, sulfuric acid hidrogennya ada 2, tetapi di produk sulfuric acid kehilangan H. Jadinya H cuma 1 kan. That's why in sulfuric acid we call it as acid. Kita sebutnya dia asam berdasarkan si Bronsted Lowry. Gitu. Berarti pasangannya adalah base conjugate. Sementara water ada H, ada O, hanya ada 2. Tapi di produk dia jadinya hanya ada 3. So in this process, in this reaction, the water is accept proton. Makanya karena accept proton itu adalah base, so water it is base. Tetapi di sini jadinya adalah pairnya acid conjugate. Nah, nanti ada reaction di mana water itu sebagai acid guys, bukan base. Karena water is amphoteric substance, which is it can become acid or base. And the last one is Lewis. It is about electron pair. Kalau ini nama donor, berarti di sininya adalah acceptor. Acceptor elektron, pair elektron. Sementara yang di base adalah donor, pair elektron. Berarti harus apa? Yang satu punya pair elektron, yang satu enggak. Gitu. Sementara kalau dari sini reaksinya sudah kelihatan kan? Dia kehilangan atau nambah H+. Sementara kalau di sini biasanya nggak kelihatan guys. For example yang tadi. NH3 react with BF3, it become NH3 BF3. Nah, in the Lewis itu biasanya terbentuk coordinate covalent bond. Gitu. Kenapa? Karena di NH3 dia ada pair elektronnya. Nah, di F3 dia nggak punya. Nah, nanti this pair electron will bond with BF3 terus become saltnya gitu. So, karena dia punya pair elektron, dia yang mendonorkan si pair elektron. Menurut Lewis, NH3 di reaksi ini adalah basa or base. While BF3 karena dia accept the electron, we call it as acid. Ininya apa? Ininya adalah saltnya. Nah, kalian bisa melihat nih perbedaannya. In the Bronsted-Lowry reaction, biasanya dia produknya itu tetap ada 2. Atau kalau misalnya di sini ada 3, so the product juga ada 3. While in the Lewis reaction, only one product. Karena dia nanti akan berikatan jadi 1. Jadi coordinate covalent bond. Any question, guys? Wait. Ada pertanyaan dulu?
Mungkin belum, Miss.
Oke, kalau belum kita coba cek ya. Ada 5 pertanyaan lagi nih. Wait, I will give you the link. In the chat room. gas. Yang paling bawah ya linknya. Where's the other? Ten student? Sinyalnya lagi nggak bagus kak guys. Dari tadi ada yang keluar masuk mulu ini. Alright. Tunggu beberapa lagi. Okay, let's start. So there are 5 questions, and each question you need to answer multiple choice question, guys. So don't worry. And just like the start, nanti di akhirnya juga akan ada yang paling tinggi nilainya itu siapa. Let's check. Which is the properties of base. Sour in taste, smooth in touch, proton donor, or electrons acceptor. Time's up. Let's check. Wait, I think there is problem of my screen. Bentar ya. Oh, udah kelihatan. Bentar guys, ini share screen aja. This one. So, alhamdulillah banyak yang benar. Smooth in touch atau dia sedikit perit kan guys. Kalau sour in taste, alhamdulillah udah salah semua because this one is acid. Proton donor is acid based on Bronsted Lowry. Electron acceptor, it is acid based on Lewis. Tadi kan kita udah belajar. Next. Question number 2. Which of these substances is an Arrhenius acid? C26, CH4, HBr, kalau H. Gampang. Time's up. Okay, good. The answer is hydrochloric bromide acid, HBr. Kenapa sih C2H6 sama C4 salah? This one it is organic compound, guys. Organic compound. And we already learned that in the acid of Arrhenius, hydrogen in the left side. Adanya di sebelah kiri. Kayak HBr, HI, HCl, dan sebagainya. Sementara hydrogen in this one, C26 atau C4, itu adanya di sebelah kanan. Berarti ini sudah jelas bukan acid. Jadi jangan mentang-mentang, oh ada H-nya itu adalah acid. No. Ada rules-rulesnya. And how about this one? Guys, this one is OH. So hydroxide ion. Hydroxide ion, it is not acid. This one is base. Oke. Jadi kalau yang basa mah OH-nya di sebelah kanan, tetapi yang asam H-nya di sebelah kiri. Based on Arrhenius theory. Oke, next. Question number 3. According to the Lewis definition, a base in, sekarang Lewis, tadi Arrhenius. Proton donor, electron pair donor, hydroxide ion donor, electron pair sector. Time's up. Oh, good job. Base in the Lewis, it is about the electron pair donor. Jadi kan tadi ada 3, Arrhenius, Bronsted-Lowry, sama Lewis. Arrhenius mah H plus O hamin, Bronsted-Lowry-nya mah proton donor atau acceptor donor. Proton donor atau proton acceptor. Jadi ngomongin proton, tetapi kalau di Lewis kita ngomongin electron pair. Yang base dia punya electron pair. So this is the electron pair donor, it is base. Electron pair acceptor, it is acid. Jadi tinggal dibalik aja guys. Kalian bisa hafal salah satu. Misal, kalau acid proton donor, berarti itu untuk di Bronsted-Lowry, dia sebagai donor. Tetapi kalau untuk di Lewis, dia sebagai acceptor. Gitu. Begitu juga kebalikannya untuk basa. Next question. Question number 4. Which statement is true? BF3NH3 is an example of Bronsted-Lowry reaction. Atau the formation of water is an example of Lewis reaction. Bronsted-Lowry state, acid and base react through proton transfer. The dihydroxide ion is normally a Bronsted-Lowry acid. Time's up. Good job. So, yang benar adalah si Bronsted-Lowry ini kita ngomongin about the proton transfer. Ada yang donor, ada yang acceptor kan tadi. Sementara kalau yang tadi BF3NH3, kita tadi barusan belajar, it is not Bronsted-Lowry but Lewis. Hampir mirip-mirip ya guys, Lowry and Lewis. Tapi kalian harus bisa bedakan. BF3NH3, it is an example of Lewis structure atau structural reaction. Kalau formation of H2O ini beragam. It can be Arrhenius, it can be Bronsted-Lowry gitu. Terus kalau Lewis kayaknya enggak. Cuman dia lebih banyak di Arrhenius karena menghasilkan air. Kalau dihydroxide ion is normally Bronsted-Lowry acid, it is not because this one is Arrhenius. So the correct answer is yang C atau yang nomor 3. The last question. Question number 5. Which of the following represent a Bronsted-Lowry conjugate acid and base pair? Jadi acidnya dulu baru base-nya ya. SO32- menjadi SO2, atau CO32- menjadi CO, atau H3+ menjadi H2, atau NH4+ menjadi NH3. Kalian kalau pakai HP itu kan lebih jelas ya. Kalau ini kan karena nanti digabungkan jawaban kalian jadi kecil. Oh, berarti kita perlu belajar lagi tentang glossolalia ya, pertemuan berikutnya. So, tadi glossolalia conjugate acid and base, it is about the transfer of proton. Ada H plusnya. Acid dia punya H, ketika dia jadi base pair berarti hanya hilang. Kalian bisa lihat di SO3 dia nggak punya H. Berarti apa? Berarti dia nggak bisa jadi acid karena dia nggak bisa ngedonor dong, nggak punya H. Di CO3 juga kayak gitu. Di H3O dia punya H, punya. Tetapi jadinya dia H2, bukan H2O. Ya kan? Seharusnya ada O-nya juga karena yang didonor itu adalah H-nya doang. Sisanya dia akan stay or tetap. Nah, kalau di NH4 sama NH3, we can see this one. Hidrogen di NH4 ada 4. Tapi di NH3 ada 3. Berarti apa? NH4-nya, NH4+, hidrogennya dia donor H+. Makanya dia berkurang ketika di produk menjadi NH. Gitu guys. So let's see which one has the greatest point. Oh, Meti is meta, right? Meta, good job. And for the second one is Raka. Okay, guys. So this is the end of my explanation. And then this any question before I cross the guys. Ada yang mau ditanyakan dulu sebelumnya? No. Udah pada paham? Are you sure?
Insya Allah, Miss.
All right. See ya. Okay, guys. So for today, we already learned about the properties of acid and base, and the last one is the theory of acid and base. For the next meeting, we will learn about the Bronsted-Lowry reaction. Yeah. And next for the Friday, kita ada praktikum, jangan lupa. Jadi, see you for the next meeting, guys. Thank you. Assalamualaikum warahmatullahi wabarakatuh.